Hi, I'm William, reporting for the Fun Robotics Network. I'm here at the Southern Cross Regional with Team 4774, the Drop Bears. They have an incredibly innovative algae shooter that shoots into the barge. It's one of the most unique robots. Learn about their awesome hang and their algae intake, all on Behind the Bumper. So, when going into starting the season, what was your strategy?
Well, at the beginning of kickoff, we were kind of thinking if we wanted to do an algae or a coral bot. So we brainstormed a few ideas and we thought that both would be very good robots, but we found that algae could be a more interesting and could complement the other robots well, because we knew that there would be probably a lot of coral bots. We also thought that we've been a shooter bot for the past 3 years, so we really liked that realm, so we decided to stick to it. And yeah, we thought the coral was interesting, but we would maybe find difficulties with alignment. And again, we were just used to shooting, so we decided to test it, and we found that it was quite effective. We decided to do that by having an intake where the bot can intake from the floor, as well as using the shooter itself to intake from the reef. We also have a coral mechanism that's attached to the shooter, which we will go more into depth later. And it basically allows us to deposit a coral on level 1 during auto, because we thought that ranking point was really important. So we wanted to try to optimize it and optimize all the ranking points that we have. We also decided to do a deep climb because we would be able to maximize the amount of points in endgame. And yeah, so that's basically kind of our strategy.
Alright, so with actually designing and producing the mechanisms that are on the robot, we have a lot of modular sort of iteration. So we've split it up into 3 main systems. We have the climber here, which I'll go into detail soon, the shooter, which is everyone's favorite mechanism, and the intake out the front here, which deploys outwards. Now, one of the things that we try to do when we design our mechanisms is to make it as simple as possible for controls to actually handle the mechanism. So that's why the entire climber ecosystem, which is up the front here, is entirely powered by one single motor, which would be this winch right at the back here. So the way it works is the climber here, the latch deploys outwards, or the winch allows this gas strut here at the front to push it forwards. As it pushes it forwards, these 2 climber guides, which are currently being maintained with these little tabs at the back there, will be pushed forwards, and then gravity will just do its work and they'll come forwards and stay down. We've got a little damper here just to minimize the impact on the front of this plate. And this latch will come forwards and be ready for the cage to come into it. Now, for software, we have a localization system, which my associate will go into further detail soon. But the short story of it is it will automatically lock onto the nearest cage that we have to our robot. And once it locks on, we just drive forwards onto it. And these guides allow the cage to come in and press down on these hooks here until eventually they spring back and we can climb on that cage. All right, so here we're going to have a demonstration of the climber. And you'll see the winch unspool and the climber come forward. Another small part of the climber down here, small but critical, is this kicker here. This is what keeps the bottom of the cage, where that hole is, stationary while we actually bring it back using this, use the motor, using the winch motor. And the way that it works is that it's also actuated by this moving arm. While this arm is in its stowed position, back here, while this arm is in its stowed position, the kicker is retained by the bottom of the arm, and once we actually deploy it, the kicker has constant force springs at the back, which just bring it forwards, and then a latch mechanism back here slides into place into a hole that we've got into the extrusion here, and that means that when I try and push it back in, I can't actually do anything about it. So that's our climber. Out on the front here, we have our intake. This intake is a little bit different to what we've done in previous years. This one has 2 separate arms with inclined wheels. What this essentially functions as is a self-centering mechanism, as you'll see as we'll test it very soon. And this crossbar here, as well as being our tilt bar, actually kicks our algae into the spinning flywheels here and enables us to actually intake it almost flawlessly almost every time. The Omni wheels here enable us to minimize any of the still uncentered. If the algae is still slightly uncentered, the Omni wheels will take care of it as the injectors run it towards the center. So we'll run a small little intake now. And there it goes. And from the side, we'll intake our algae. And you can see there that it does a nice little job of centering it so that we are ready to shoot it. So I'll pass on back to William.
So I see how you can intake these algae into the shooter. So how does this shooter actually work? How is it always accurate into the barge?
Yeah. So this shooter here there's a huge amount of work that goes into it, both mechanically and on the software side. I'll talk a bit about the mechanical side first. So here we've identified that we don't actually need an elevator. We can do everything just by tilting this shooter up and down. So we have our two massive spur gears here that tilt the robot. They're all powered by this motor up here, which actually, when it is driven, it actually rotates around this top shaft here. And it allows us to have a really, really compact system up on the top of our robot, which we found is really, really good. It helps keep our CG a bit lower, and we end up with a nice, compact, and very, very fast system. Then that is all connected to the back of this shooter frame here. So that we tried to minimize the size we have. The algae is a really, really big game piece, and in order to keep it inside your robot, you need some really, really big mechanisms. So we've made this ring here, which allows the ball to sort of stick out the back, and we take up much, much less space in our frame perimeter. Other than that, it's more or less just your average flywheel shooter. We have the top and bottom here. They've got mechanism wheels on here. This aids in intaking. And then we've got some gears and flywheels down there just to add some more mass, because these balls are really, really hard to shoot. We found that over time. All of this is paired with our targeting. So we have very, very, very good localization on our robot this year. We have implemented a system of 2 turreted cameras on either side of the robot. Now, once these see tags, they start updating our position on the field. And that then allows us to use our previous position on the field, and every control cycle, we update the position that we try to search for. So we essentially track the tags around us on the field. And we have a special, we have an algorithm in there that allows us to calculate if there's occlusions in our way. We don't want to look at those tags and everything. All of that allows us to really, really be exactly where we know exactly where we are on the field. Aids us a huge amount in auto, and especially for shooting into the barge. It is a very, very hard problem, and we really need to be quite accurate in where we shoot. And we've managed to achieve this. You'll see in some of our matches. Now, all that, we also have it paired with a measuring system. So we actually measure the algae. We found that the difference between algae size had a massive, massive effect on how we actually shoot the ball. So we have a system that runs these 2 injector wheels at the back here. They'll spin at a constant 200 RPM. And then once the front flywheels here, we're recording their position. We detect when they've moved a very, very small amount. We record the position on the injectors, and then we have applied that into a scaling system, and we scale it to the sizes of the algae. We feed that into our lookup table as well. So we take into account the size of the algae, the range at which we are from, and then we give it a specific angle and a specific speed to take the shot. And I can show that now.
That is such a cool shooter.
We can also do intakes from the reef. All of that, again, done with our tilt mechanism. We do low and high intakes from the reef. I'll show that now.
So another question about it is, there's always the auto ranking point. How do you ensure that you can kind of get that? I know you could leave, but how do you make sure that you can get that auto ranking point?
So I mentioned that we want to make these as mechanically simple as possible. And so going into designing this mechanism, we already knew that we had the shooter and that we were going to use it to intake from the reef. Now the reef algae is very close to where you want to store coral. In fact, it's on the same exact field element. And so we're thinking we can implement this coral mechanism into our shooter. So I'm just going to press the brake. Yep. And so this gets brought back and the coral is essentially just jammed in this space here. As our shooter flywheels go into intake in this direction, the coral is spat out. And in that way, since the part of the reef that we're intaking from is the L2 algae, this is lined up exactly to drop it directly into the trough. And assuming our Alliance teammates are feeling like they want to move in order, we get the coral ranking point.
This is just an incredible design. And I just really love the fact that you went out of the box thinking and chose to shoot the algae in the barge. It's one of the coolest things I've seen. Thank you so much for sharing it with us. Thank you very much. And this has been 4774, the Drop Bears on Behind the Bumper.
Thank you.